Uh, okay, so I'm Aniket. I'm from Tata Institute of Social Sciences, a School of Habitat Studies, and I'm a PhD scholar. And I just want to talk today about um, doing basic digitizing using your simple features in R. So that we are going to do using Google Maps. So we're going to collect the lat long from Google Maps, and then we are going to insert it into a geometry in simple features. So we're going to record it in its geometrical form. One thing that I need to mention here is that when you record any object, okay, or any point from its latitude or longitude, you need to make sure that the x, okay, is nothing but your longitude, and the y is your latitude. And this is because in your coordinate reference system, in the xy plane, your longitude intersects or cuts the x-axis, okay, and therefore assumes the equation x equal to longitude, and your latitude, uh, the intercept of the latitude is on the y-axis, okay, so it assumes the equation y equal to latitude, okay. So therefore, if when you're recording your points, you need to be careful that if you say record a point over here, okay, and you see it as 19.31922, which is obviously the latitude, and this is the longitude, you need to invert it when you're actually recording it in your simple feature. So your x becomes 72.87414 and y becomes 19.31922. Okay. So let us start recording some points from the Google image. So what you do first is that you invoke the simple features. So that I will do in my script library SF, and we'll just run this. Okay. So now what we need to do is polygons need to be entered as lists. Multipoints need to be entered as matrices. Multilines need to be entered as lists. So this is something that also one needs to remember, that when you are making a simple features geometry, your multiline, your points and multipoints are lists, and your multilines, okay, and your polygons, sorry, my bad, these are matrices. So I'm talking about which data structure you need to use in R, and your multilines and polygons are lists, okay. So but it is actually, these are actually lists of matrices, okay. So you need to make a matrix first, and then you convert the matrix into a list to represent a single geometry object, okay. Now what you basically do is that, say for example, this is a single point that I want to record somewhere in this creek. So I copy it, okay, and in the R interface I make this as a vector, and I interchange the positions of x and y for the same reason that I have mentioned earlier. So this is x and y. Okay, this is my x longitude and y is the latitude. And then I can actually save it as a point, okay, by saying st underscore point. Let's see first if it accepts it. If it accepts this, accepts the coordinates in this form, and it does. Okay, so so point you can also insert as a vector, and then you can save this in a variable called, say, for example, point. Okay, point one. Similarly, if you want to insert multi-points, what you do is you make a matrix. Okay, so one way to do that is um, you say um, you say rbind, and then you enter the list of points, okay, that you want to make into a multi-point. So say, for example, some of these locations, I want them as multi-points. I want to insert in my multi-point file. So what I do is copy. Okay, I'll just close this to get rid of the additional stuff. Okay, then and let's take one more point. Okay. So these are my 4 points, which of course I will have to I'll have to invert uh, the position of the x and y. Okay, the lat long. So I say multi-points. Okay, I already had something called multi-points here, so I'll say multi-points 1. Okay, so these are my points. And in order to, so, of course, when you actually try and view, you get your x and y, but you need to interchange it. So what you need to do, one way you can do it is multi-points 1, okay? And of course you have row and column, so the column, you can put 2 first, okay? And then one, since we have only 2 columns, so we can say from 2 to 1, and it gets interchanged. Else you can also do cbind, cbind 2 and then cbind it with 1. And then I'll save it in the same variable. I won't take another variable. Okay, so now I have my x here, my y here. And then what I can do is I can convert it into a list. So, okay, so now in this case, it's a multi-point. We don't want to make a line. So what we do is we do we do a we use st underscore uh, multi-point, okay, and then we just say multi-points 1, and if we run that, we get a multi-points. So we can say multi-points 1, it becomes an R object, okay, but it's not converted into a geometry yet. So in order to convert it into a geometry, or a simple, or what is known as a simple features column, we say st underscore sfc. So it says st as simple features column. And what we need to do is we need to give a coordinate reference system. So in this case, I'll give a WGS84, a spherical coordinate reference system. So I'll just say 4326. Okay. And there we see it gets the geodetic properties. of the coordinate reference system. So we will save this as, again, we won't keep many names, okay, many variable names, so as to avoid confusion. If you want to do calculations, obviously you need to transform it. So you say st underscore transform, and you can transform it to your WGS, your UTM-43. So your CRS is equal to UTM-43. Um, so the projection, the EPSG number of UTM-43 zone is okay. It's loading here. It'll load in a minute. This site unfortunately is a little bit slow. So it's 32643. So I put this as the CRS, and then when we run it, you see that it has been projected to UTM zone 43, and your bounding box, instead of showing it um, in the coordinates as a coordinate, um, it shows it as map units. So it shows in Cartesian coordinates instead of the lat long. Okay, so that's how you get your points. Similarly, if you want to get your line, you need to make a list. Okay, so say for example, I want this a part of this river or a section of this river. Okay, so I just say, I'll just collect the points first. So I'll just collect a couple of points here. So what you do is just right click and then click on it, and you can grab the point. Um, so what we'll do is this, we'll call this multi-line. Okay, so we'll save it first as a, we'll r-bind these points so that we get them as a matrix. Okay, and then of course we'll save it to a variable called multi-line underscore 1. Okay, actually it's only a single line, but you can store many lines in one shapefile. So that's the reason I'm calling it a multi-line. And then I run this. Again, now we need to interchange the columns. So multi-line 1, and we'll put 2 to 1. Okay. And we'll again save it as, oops. We'll again save it in the same variable. So when we do multi-line 1, we now have X and Y in their appropriate places. Okay. Then what we do is we make it into a list. So if you want to make a, a line out of it, so you say multi-line string. Okay. Uh, give, you say list and multi-line 1. Okay. And let's see first, before we store it in a variable, whether it works, and it does. So I save it as multi-line 1. I call it an object. Okay. And then what I do is I make it a simple features column object. Okay, sorry, and we say multi-line 1. Okay, and save it in the same variable. Of course, here we need to mention the CRS. Okay, the 4326, which is your standard WJS 84. And here we have our multi-line 1. Okay, if we actually plot both of these, okay, so if we say ggplot we say ggplot plus geom underscore sf, okay, multipoint data equal to multipoint 1, okay, and size equals 2, color equals red, okay, plus geom underscore sf. So we want to plot it in the same, on the same canvas, okay, geom underscore sf multi line 1. Essential to mention it, always better to mention it in the with the argument, uh, and color equals blue, okay, and if you want to label it, plus geom underscore sf data equals multi-line 1, and in your aesthetics, okay, we say, so you say geom underscore sf underscore 1. Way to do it is label, of course one is text, okay, you say label equals uh, river, okay, and let's run this. Okay, so here we see the river, which is this one right here, and we see our various points that we had digitized. You do the same when you want to if you want to digitize a polygon, but it's very important that when you digitize a polygon, you need to close it. So here we can see that your y has been the graticule, your y is your latitude and your x is your longitude, okay. So similarly, if you want to make a polygon, so say for example this particular area you want to polygonize, so you just gather the points first, okay, so you'll create a vector of points that you want to actually r-bind into a matrix, okay. So we'll just do it a little crudely. So we won't collect a whole many points. The ideal way to do this is actually digitizing. However, uh, digitizing you can only do in your GIS software. Okay, there is no tool for digitizing in R. And you can, however, make a shapefile and then pull it into R for further analysis. So remember, we are not exactly creating the shape as is. We're just polygonizing it to give it a rough resemblance to the actual shape of the polygon. So this is just going to be a rough outline. Okay, and we repeat the very first set of points again so as to close it. Okay, and then we are bind it so that we can get it as a matrix. Let's see how it binds. There we are. So your first and your 13th point are exactly the same. So that is how you close a polygon, and we call it multi-polygon or single polygon 1. Okay, so that's done. And what we can do is that we can then convert, then we can use st underscore polygon function to polygonize this, and you need to enter it as a list again. And there we have it. So we'll store it uh, into a variable with the same name. So it will convert it into a object. And what we'll do is this, we will convert it into a simple features column and give the same CRS. Okay. And again, we'll call it single polygon 1. Okay, so now if you want to view the polygon that we have digitized in addition to these points, what we'll do is we'll just add another simple features geometry in your ggplot, and we'll say data equals to single polygon 1 fill equals, say we'll give it a color. Okay, so for some reason it's not, let's see what the problem is here. Okay, so it was some issue, there's some issue with the extents. um, so let's see if it just plots this. Okay, so it's plotting just the, okay, so here's the mistake that I made again. I have not, when I did this, I forgot to interchange. Okay, so I forgot to do this. Single polygon one, so it's still reading as lat and long the other way around. So we are having uh, an inverted image where this is showing the longitude is being plotted on your y instead of your x. Okay, so this is the same problem that we had in the lecture, but unfortunately I was not able to correct it at that particular point of time. So let's interchange this. Okay, so you say single polygon one, you say single polygon one, two, and then one. So two to one. Okay, now let's see how it looks like. Okay, so it's still not, so we'll have to run it right from the beginning. Okay, there we go. Okay, now let's see. Okay, now we have it, the x and y in its right place. Do this and then do this. Okay, now let's plot this. Okay, so it was giving that particular error where it was showing an issue with the coordinate system, and that's exactly what the problem was. Okay, and now it shows everything in its proper place. So it's showing the area that we have digitized, it's showing the polygon that we have digitized, is showing the river, and it's showing the multi-points that we have digitized. So I think this is what I wanted to clarify in this particular recording, and I hope that you're able to use this to your advantage if you're digitizing from Google Maps directly into R by using these points. And so be careful of your lat long, what you choose as your lat and what you choose as your long. That is the key thing to remember while digitizing. Okay, so very good luck for your assignment, and I hope you're able to ace this particular assignment. Okay, so have a nice day. Bye bye.